Welcome to a new tutorial, guys. This is about covalent compounds. So we will need the periodic table on hand just to get the information that we need. Covalent bonding forms when two nonmetals get together to form a compound. Nonmetals normally have 4 or more electrons in the last level of energy, so they will share electrons with another nonmetals. Remember that in the ionic bonding, the nonmetals are the ones that take the electrons. In this case, there is no transfers of electrons, only a sharing of electrons for both of them. Now, let's work out some examples. First, when the elements are the same. For example, one chlorine atom that will be combining with another chlorine atom. In this case, both of them need one extra electron to complete the octet. So they will be sharing one pair of electrons, and in this case, both chlorine atoms will complete the octet by sharing them and forming the chlorine molecule. Now, when we have another element like oxygen that has 6 electrons in the last level, they need 2 to complete the octet. So in this case, oxygen will get together with another oxygen to form the oxygen molecule, but in this case, instead of only one pair of electrons, they will share 2. So we will have a double covalent bond. When nitrogen gets together with nitrogen to form a compound, the nitrogen molecule, they will be sharing 3 pairs of electrons. So they will form the nitrogen molecule with a triple covalent bond. In this case, note that none of the elements lost or gained electrons. They will be sharing the electrons that we call single, double, or triple covalent bond, depending on how many bonds are involved in the molecule. And since all of the elements are the same in the chlorine molecule or the oxygen molecule or the nitrogen molecule, they will be forming a non-polar covalent bonds because the electronegativity of both will be exactly the same. Remember that the electronegativity is the force that an atom has to attract those pair of electrons in a bonding. So if they are the same atoms, they have the same force. Now, what happens when the elements are different? Like, for example, oxygen getting together with hydrogen. If hydrogen shares one of the electrons with oxygen, hydrogen gets the configuration of helium and is kind of happy, but the oxygen is not because it's going to have only 7. So we can fix that problem combining another atom of hydrogen with oxygen, and so we can have the molecule of water. Be sure that you notice that the bonds are simple bonds, and we have different elements there, so we are going to have polar covalent bonds in this case. When nitrogen gets together with 3 atoms of hydrogen to form ammonia, something similar occurs because the hydrogen will be forming single bonds with the nitrogen, 3 single polar bonds with the nitrogen, since the nitrogen and hydrogen have different electronegativities as well. In the case of carbon and oxygen to form carbon dioxide, the carbon needs 4 more electrons, so it needs 2 oxygens to form 2 double bonds that will be polar, but since they are aligned and they are canceling each other, the molecule of carbon dioxide is non-polar, as we discussed during class. Now, again, notice that the 2 extra electrons that the oxygen needs in the molecule of water come from the hydrogen, so both can complete the electronic configuration of the noble gas near to them. That water and ammonia had only single bonds. Hydrogen actually never formed double bonds. And in the case of the oxygen, they will be forming double polar covalent bonds, 2 actually. Now, how we work out the formulas. First, we need to talk about the oxidation numbers. When we talk about oxidation numbers in metals, we said that it was the charges of the ions. But the problem is that here we don't have metals and we don't have ions. They never form, the nonmetals don't form ions when they get together, forming covalent compounds. So we cannot speak about charges. But the oxidation number or oxidation state will be equal to the amount of electrons shared by the atom. For example, in the case of ammonia, nitrogen is sharing 3 pairs of electrons, and hydrogen is sharing 1 electron each. So since the nitrogen is sharing 3 electrons, the value will be 3. The hydrogen shares only 1, so the oxidation number or oxidation state for hydrogen will be 1. But we talked about positive and negative charges. So the positive charge will be for the hydrogen because it's more electropositive, or the nitrogen is more electronegative. The oxidation number then for nitrogen in ammonia will be -3. 3 because there are 3 electrons involved, and negative because it's the more electronegative. And the hydrogen will be +1 because it's sharing only 1 electron, but the nitrogen is more electronegative, so the hydrogen has to be positive. In the case of the carbon dioxide, we have 4 electrons for the carbon and 2 for the oxygen. We know that the oxygen is far to the right on the periodic table than carbon, so oxygen will be more electronegative. So in this case, the oxygen will be sharing 2 electrons. So the oxidation number will be 2, but since it's more electronegative, it will be -2. And the carbon in this case is acting with +4 because it's sharing 4 electrons, but the oxygen is more electronegative. There are several rules about oxidation numbers and how to assign that, but that will be in another video far away in the year. So far, and just for now, we can have only 2 rules. The oxidation numbers of hydrogen in a compound will be +1. There are some exceptions, and we will see that in the future. And oxidation number of oxygen in a compound will be -2, and also there are some exceptions that we will not cover right now. Okay, this is it for now. I hope you like it, and have a nice day.